Now we are going to derive the expression for pressure in terms of kinetic energy, mean kinetic energy. How to start with? In the previous video, we have derived the expression for internal energy of the gas. That internal energy is mentioned by the letter U. U is equal to, what is the expression? 3 by 2 nkt. So this is the expression. Therefore, U is equal to 3 by 2 nkt. So clear, this expression was derived already in the previous video. Okay, we know the gas equation, ideal gas equation, PV is equal to nkt. So this part can be removed. Internal energy is equal to 3 by 2 nkt can be replaced by PV. Are you clear? Now our aim is to get the expression for pressure. So keep pressure in one side. P is equal to 2U divided by 3V can be written. Are you clear? Now I am going to introduce another factor called, what is this? U. What is U? Internal energy per unit volume. U is called internal energy. Internal energy, if it is calculated per unit volume, that factor is called small u. Here U is there, internal energy, that is divided by volume. Therefore, U is equal to, and we can write it as U by V. U divided by V is nothing but small u. That internal energy per unit volume is simply called as internal energy density. Internal energy density, because it is divided by volume, no, that's why this is called internal energy density. You should understand the meaning. Okay, now U by V, capital U divided by V can be replaced by small u. So the next expression I can write 2 by 3 into small u. Are you clear? How the pressure is measured in terms of internal energy density? The pressure of the gas is equal to two-third of the internal energy density. That is internal energy per unit volume. We can call it as internal energy per unit volume. How pressure can be measured now? How pressure can be defined? Pressure of the gas is two-third of the internal energy per unit volume. So in that format, pressure can be measured. This is one of the formulae from which pressure can be measured. Understood? Very important formula. Now you simply block this. Are you clear? But in the next expression alone, we are going to measure the pressure in terms of mean kinetic energy. Understood? Now we are going to derive the pressure in terms of average kinetic energy per unit volume. Average kinetic energy per unit volume. How to start with? In the beginning of the lesson, we have derived the expression for pressure of the gas. Pressure is equal to 1 by 3 Nm small n m V square bar. Are you clear? Already we know very well that what is V square bar? That is mean average speed. Mean speed of the gas. Are you clear? So here, whenever you see the bar, it shows that average. Are you clear? You have to understand that why bar is written. Are you clear? So this expression was already derived in the beginning of the lesson itself. Now here, I am writing this n into m within the bracket. Here this n into m, it can be combinedly called as rho. This rho is called as mass density. This rho is nothing but Nm, that is nothing but, what is this? Mass density. Are you clear? Already we have learnt what is N. N is called number density. Rho is equal to, instead of N, N by V can be written. Total number of molecules present in the particular volume. Total number of molecules present in a particular volume. This is called number density. number density into mass. Number density into mass, that gives you mass density. I'll write the formula now. Mass density rho is equal to number density into mass of each molecule. Mass of each gas molecule. This is appropriate formula. Don't get confused. Are you clear? So here this n into m is expanded here. Therefore n into m can be replaced by rho. So pressure is equal to 1 by 3 rho v square bar can be written. Understood? The next step what we have to do here, multiply by 1 2 and divide by 1 2. Pressure is equal to 2 by 3 into half rho v square bar. In that format we can write. Here already I have told about the nature of this expression. That one gives you the average speed. Are you clear? Average speed of the molecule. Since it is average speed and this one is the mass density, if mass density is multiplied by average density, that one gives you the average kinetic energy per volume. Are you clear? Because V is there. So the entire factor, how it should be called? Pressure is equal to 2/3 of this entire factor can be written as Ke bar. Ke bar. Whenever you write bar at the top, that shows that average value. Are you clear? That bar indirectly tells you the meaning of average. So what is pressure? Pressure can be measured in terms of average kinetic energy per unit volume. 2/3 of pressure is equal to 2/3 of what? Average kinetic energy, average kinetic energy per unit volume of the gas. Are you clear? The pressure is a measure of, so clear, if you want to calculate the pressure of the gas, how it can be measured in terms of kinetic energy? That is equal to 2/3 of the average kinetic energy per unit volume of the gas. Here indirectly volume is there, within the expression V is there. Kinetic energy is measured in terms of half mv square. V square bar, it indirectly tells the average value. So Ke bar is expanded and it is written here. So pressure, it is measured in terms of which one? The average kinetic energy per unit volume of the gas. How many times? 2/3 of the average kinetic energy per unit volume of the gas. That one gives you the pressure. Capital P must be written. Are you clear? Capital P must be written. Don't forget. So that is the expression for pressure of the gas. Pressure of the gas. Okay.